Okay, in the last segment we looked at this prediction versus performance conundrum in a specific diet, and we're going to take a look at how do you resolve these things. We had a pretty good idea as we ended up in the last segment looking at the prediction from NRC, and the post-NRC work was pretty much in line with what the cows were actually doing. And so that gives us a good indication that NRC is probably pretty much on the mark, but we need to be able to actually verify that. This is where we were. The model that was used to formulate the diet was predicting 132 pounds of methionine allowable milk. NRC was predicting basically 86. So how do we resolve these differences? There's two things we need to keep in mind if we're actually going to do this and have a resolution to them. The first one is that if the Model A predictions are reliable, if this is a reliable prediction and along with the methionine supply prediction that goes with it, then if we add lysine and methionine to the diet, that will do absolutely nothing. According to what Model A is telling us, the cows are already swimming in lysine and methionine, and adding more is not going to produce any response. That's the first thing we have to keep in mind. The second point we have to keep in mind is that if we go ahead and add additional lysine and methionine and the cows do respond, then there's a message there as well. That tells us that this is not a reliable prediction. So it's really pretty simple, and I go for simple. I can understand simple. This is what we do. We provide the additional lysine and methionine and let the cows decide. They will never get it wrong. They'll always have it right. When you make that suggestion, this is typically what you hear. I can't afford to spend more money on amino acid supplementation. But let me ask a question. What if the producer is already paying the cost of effective amino acid supplementation, but he's not getting it? Well, how can that happen? Number of ways. If feed dollars are not being efficiently allocated at formulation time, it's very easy to build in unintended and unrealized cost to the diet. Very simple. One of the ways you can do that is if the formulation focus is not on amino acid supplies, that cost goes up very quickly. Typically, that would be a scenario where you've already got a diet and you want to boost lysine and methionine, so you chunk on a lysine supplement and you chunk on a methionine supplement. That's the quickest way I know to make a very expensive diet, because you're only focusing on the supplements, and in reality, any ingredient in that diet that provides true protein is also going to provide lysine and methionine and other amino acids. But you're not focusing on those, you're focusing just on the supplements. Sometimes the software can't accurately address amino acid optimization. I can tell you right now, if the model and software implementation of the model can't reliably predict supplies, you'll never have a cost-effective amino acid optimization, because the picture that the optimizer gets of the relative value of all of the ingredients contributing to lysine and methionine and other amino acids is dependent on what it receives from the model in the terms of predicted supplies. So if those supply predictions are not accurate, those relative economic values are going to be very skewed, and you'll never have an accurate, cost-effective amino acid optimization. The other ways that software can play into this is if you have a nonlinear model and you have a solution process that's cantankerous, it's time-consuming, and it's not consistent, you just don't want to work with it. And sometimes you can't work with it. You don't have time to wait on that solution to solve. So what do? Almost all of us will do this. We'll manually formulate the diet, and there isn't one of us who doesn't think we do a great job at this. We all think we just know exactly what the relative values are, how to put things together. Let me show you a diet that was manually formulated by someone who's very good at manually formulating diets. Let's take a critical look at it. Here's the diet. This is the NRC evaluation of the diet. This was 53.6 pounds of dry matter. You can see the fiber carbohydrate fractions here. The diet's providing 179 grams of lysine, 61 grams of methionine, 2.92 to 1 ratio lysine to methionine. $7.30 is the cost of the diet. Now, you can see there's two other columns up here. One says cost window, the other one says final diet. What we're going to do, and to illustrate the role that optimization plays in all of this, robust optimization, we're going to target this same gram total of lysine and methionine in this diet. But we're going to allow the optimizer a range of 1,000 to 4,000 grams of MP. And basically we're telling it, find us the lowest cost MP point that still provides us 179 grams of lysine, 61.2 grams of methionine. Now how can we do that? Well, this whole idea is based on what NRC tells us in Chapter 5. The first message in that chapter that we're going to look at is that amino acids, not protein per se, are the required nutrients. And I'm going to paraphrase that. Amino acids, not MP, are the required nutrients. So it's amino acids we need to focus on. The second statement is this. NRC tells us if we implement diet formulation strategies that increase lysine, methionine, and MP, that can result in more actual milk than MP allowable milk. In other words, that's just another way of telling us it's not MP, it's the lysine and methionine content in MP that's driving milk yield and driving true protein yield. Okay? And the third message is simply this. NRC encourages us to combine protein supplements and roomly protected amino acids in ways to meet amino acid requirements with minimal MP. All three of these are just different ways of saying it's not MP, it's the lysine and methionine content in MP. So if we're targeting the same number of grams of lysine and methionine, we can expect the same performance. And that's what we're going to do here. We're targeting 179 grams of lysine, 61 grams of methionine. This is what the revised diet looks like. And we're doing this for the purpose of determining if we can provide those same grams of lysine and methionine at a lower cost. And you can see these are very similar. We have identical dry matter, very similar proteins, carbohydrates, 179 grams of lysine, 61 grams of methionine. So we've got a very similar diet. We should expect very similar performance from the animals. But look at the cost of the diet. $6.43. That's 87 cents per head per day less than the manually formulated diet. Okay. 87 cents. That's a huge difference in the cost of the diet. And just to give you some background on this, this was done at a training that we did late last year. The nutritionist who had manually formulated the diet brought it to the training session. He wanted to go through it. He was there, other nutritionists were in the room, and at each stage of this process, in the cost window diet and the final diet, everybody had to agree on the ingredients that were in the diet and the inclusion rates of those ingredients. We worked with it until everyone was happy with it. And there were very minor changes in ingredients, and by that I mean there was maybe one or two additional ingredients used in these last two diets. Mostly, it was changes in inclusion rates. Okay, so we've got 87 cents to work with. Everybody in the room looked at the diet and said, well, there's two things we want to change. We had a pretty small RDP balance here that was maintained in the cost window. They wanted to raise this to about 200 grams, so that was one of the things that we changed. The other was histidine-methionine ratio. Everybody wanted this at 1.1 to 1 instead of 1.03. So those were the changes that we made in the final diet. We could have done anything with that 87 cents, but that's what everyone wanted to do. So here's the final diet. Again, same dry matter intake. These measures are all very similar. We are now at 214 grams RDP balance, which is where everybody wanted to be, 67 grams of histidine, 180 grams of lysine, 61 grams of methionine. So our 2.94 to 1 lysine-methionine ratio, and here's our 1.1 histidine to methionine ratio. So where'd we end up on cost? $6.85. We're still 45 cents per head per day under the original diet. It's virtually impossible to mentally manage all of these relationships, cost relationships, relative economic values, to do all of that mentally while you're trying to manually formulate the diet. It just doesn't work, especially when you get down to the amino acid level. Okay, so here's the recap on the diet. It was a manually formulated diet. We had an 87-cent cost window to play with to improve the diet. These were the steps we wanted to take to improve that diet. Nobody wanted to go any higher on lysine and methionine. They were happy with that. And we cut 45 cents per head per day off the cost of the diet. Like I said, it's virtually impossible to manage all of that mentally when you're trying to manually formulate a diet. And that's where efficient, robust, consistent, nonlinear optimization comes in. You're still the nutritionist. You still control the nutrient profile of the diet by the constraints that you set. You describe it in nutrient supply. So it's going to be what you want. The optimization process gets you that diet that you want at the lowest cost. So again, all of these things feed into building costs unintentionally into a diet. You don't even know it, but it's there. In this situation, it was a situation where this was a cantankerous optimization process, and he just didn't have time to do it, so he manually formulated the diet. He was a little surprised at the cost, as with everyone else, that we could open up that big a cost window on it. Okay. We're going to walk through one more diet, and that one we just looked at, the 87-cent cost window, was used to trim up a few things here and there and to save money on the diet. This is another diet, 55.6 pounds of dry matter intake. You can see where the crude protein level is, 16.82. What we want to look, this was a haylage diet, so we've got a really high RDP balance. 165 grams of lysine, 48 grams of methionine. This is the NRC evaluation of the diet. Cost of the diet, $7.59. The true protein adjusted predicted milk yield is about 82 pounds, and that's within a couple of pounds of where the cows were actually producing. But I want you to look at this. We've got a lysine-methionine ratio of 3.4 to 1. So we've got a lot of lysine, which means because we have a low methionine level, we can add a lot of methionine to the diet to make use of that lysine. And once we reach the ceiling of that lysine level, then we can go above that. So we're going to do the same thing, same principles from NRC. It's amino acids that are driving milk and true protein yield, not MP per se. Again, NRC tells us if we manipulate lysine and methionine with MP, we can change milk yield, which obviously means if we can do that, it's not MP, it's lysine and methionine. And again, that's why we're encouraged to minimize MP while meeting amino acid requirements. So those are the concepts that we're going to use on this diet as well. Again, we're going to do a cost window. We're going to target 165 grams of lysine, 48 grams of methionine, and see what kind of a cost window we can open up on this diet. You can see we cut down RDP considerably, about 300 grams or so. Actually increased MP a little bit, but here's our 165 grams of lysine and our 48 grams of methionine. We still have a wide ratio, so there's lots of room yet to work with methionine. But we've got a 70-cent cost window on this diet, 70 cents. And again, we're staying right here on our milk prediction because we have the same number of grams of methionine. That hasn't changed. So what we're going to do now, instead of reducing the cost of the diet, we're going to increase methionine so that we get full utilization of the lysine that we already have in the diet. We're going to add 16% to our methionine supply, then we're going to add 20%, 25%. And we're going to watch. What we want to watch here is the cost of the diet and the true protein adjusted milk yield prediction. Okay. Very similar measures. Again, primary difference, RDP is lower, MP is higher. Total protein, 16.7, very similar. But we've got 56 grams of methionine and 175 grams of lysine. We've still got 42 cents on our cost window. And we've picked up 10 pounds on the predicted milk yield. And we still have 42 cents. So let's go to 20%. Now we're at 58 grams. These are pretty much stabilized from here on out. 176 grams of lysine, 58 grams of methionine. We're down pretty close to a 3-to-1 ratio now, which is about where we want to be. $7.30. We're up to 95 pounds on our predicted milk yield. But we've still got 29 cents to play with. So let's go to the last increment. Now we've got 60 grams of methionine. We started out at 48, we're now at 60. 178 grams of lysine, 2.97 to 1 ratio lysine to methionine. We're fine with that. $7.47. We're still 12 cents less than where we started, but we're at 97 pounds of predicted milk now instead of 82. So here's the recap. A 70-cent cost window. We used it to increase methionine supply by 25%. That's a huge increase in a limiting nutrient. That's huge. We decreased RDP by 275 grams, which is what we wanted to do. We had way more than we needed. We still reduced the cost of the diet by 12 cents per head per day. And in the process, methionine true protein adjusted milk yield moved from 82 to 97 pounds of milk. I don't know of any producer who would complain about reducing his feed cost and improving animal performance. Just like nobody breeds for less milk. Okay. It's very simple to build unintended cost into a diet, and we get the mindset that we can't balance for amino acids because there's just no money to do that. Not so. There are all kinds of reasons why unintended cost gets built into the diet. If you have an efficient, robust optimization process that fully supports all of the aspects, the nonlinear as well as the linear of NRC 2001, there's lots of room to work. So let's go back to our conundrum. What do we do to solve it? We add the additional lysine and methionine and let the cows tell us what they can do with it and what they can't, rather than to sit around the fire theorizing about it. Okay? This was the objection. I can't afford to spend more money. Well, you don't have to. That isn't necessary. I've worked with dozens and dozens and dozens and dozens of these diet workups, and I can tell you I have never seen one diet yet that didn't have an effective cost window in it. As long as it was formulated with something other than NRC 2001 and Formulate 2, there's a cost window. Okay. So the NRC amino acid submodel and the Formulate 2 tool set give us a whole different picture, a whole different perspective on amino acid balancing. When you take a diet and evaluate it in NRC 2001, you will find very different predictions for lysine and methionine supplies. You will find very different lysine and methionine ratios. The first diet that we worked with, I mentioned, had a 3.7 to 1 lysine to methionine ratio in the first segment. In the software that we used to formulate the diet, that ratio was 2.8. So it looked fine in the software. that formulated the diet. When we ran it through NRC, very different picture. There's a reason that NRC gives us this kind of a perspective. And that's because it was built from cow data. It's not fully theoretical. The cow was invited into the modeling process to provide a correction factor to the theoretical errors of the framework, of the factorial segment of the model. And the cow is never wrong. That's why NRC works as well as it does. Now we're going to take a look at what happens when you take these concepts we've talked about and actually apply them in the field, and that's where Wayne Gruenhagen and Big Gain come in. We've worked with them for the last 2 years, and Wayne is going to share with you what their experience has been working with NRC, the Formulate 2 tool set, and making the transition to a new paradigm for amino acid balancing. Thank you very much.